ex-academic here in Bristol. So, exactly, so the theme of my presentation and of my research is the causal impact of climate change on human migration. And the idea here is to explore to what extent we can study causation in human migration with a complex system approach. And the goal of my presentation is to motivate that complex system approach. And so the general problem is the following. So if we consider the general drivers of migration, one could say that these are external parameters that drive migration flows from the outside of a system. But some other people could argue that migration is the result of individual decisions in such a way that modeling causation should be done from the bottom at the level of agents. So also we should take into consideration that there's what we call the influence factor, or the influence of the decisions of others on the decision of every individual agent when it comes to studying causation in migration. So we also have to study, so to say, a level which would be in between the micro and the macro level. So just to give you an overview of why we should study causation in the phenomenon of migration, I will introduce a couple of figures. So the first figures illustrates the global growth of global migration around the world. And what you see is a global increase in the total number of migrants around the world. So from the 1970 to today, we see an increase of almost 200 million of migrants around the world. We also see here an increase in the global migrant stock, here illustrated as a percentage of world's total population. So we see that from the 1990s to the 2020, there's been a global increase in the world's total population of migrants. And finally, there is, of course, evidence of a global raise in contemporary migration crises, which is given by the total number of refugees counted in million around the world. From the 1960s onwards, we see a very sharp increase in the total number of refugees counted around the world. So the idea here, someone could say, well, migration systems are nonlinear random systems. So they evolve randomly according to chance. So the increase that we are observing is just a matter of chance. So in other words, we could let migration go and say that at some point it will stabilize, so to say, from itself. But some other people might want to argue that we need to study causation in order to understand what are the factors that do explain that global raise in migration around the world. So the research question that I put forward is the following. What are the strong points of a complex system approach in migration science? And the sub-question, how can we theorize causation in migration with that approach? So let me first introduce the general problem with causation in the science of migration. The problem is related to the standard models of migration because they do not represent the underlying causal processes of migration. For example, there you have two standard models that are used by migration scientists to calculate the likelihood of observing migration in a certain region of the world. The first one is a classical model, the Poisson model, and what we have there, we have a conditional probability, and the parameter that we use to conditionalize the number of events n that we would like to observe in the future, the parameter lambda, is an intensity rate of migration. So one could say it is not very interesting or explanatory from a causal point of view to use that model because it only says that given a certain intensity rate of migration, there will be a likelihood of observing a given number n migration events in the future. The second model is a little more interesting, I would contend. It's a Markov transition process model. And what we do there is that we model migration as a transition process. For example, we could use a very simple transition process from a state of an agent, which would be staying in a country, and we would like to model the transition to a different state, namely a state of migration. With that model, and what it says, what we have is again a conditional probability. We conditionalize the probability of observing y, which is the state of an agent at a future time step x n plus 1, and what we use to conditionalize on is a series of past states of that agent given by a series of state given there by the y's. And what the model says is that that probability, that conditional probability, is equal to the probability of observing that transition at the next time step, the state y at the step x n plus 1, given the current state that we observe, y x n. So, in other words, this model is interesting because we can introduce some memory in our model and contend that given a certain state that we observe, we can compute the probability of observing the transition to a migration state, with that model. So, from a causal point of view, it's a starting point, but I will contend that this is not enough to go further with the study of causation in migration science. So, the second aspect of the problem of causation in global migration has to do with the causal complexity of migration. Apart from climate change, various causal factors, political, economic, demographic, as well as extreme events, drive migration. As such, there is a complex causal hierarchy in migration systems. Causation can operate through a multi-level structure. As I tried to explain before, it can operate at the level of agents, the micro level. It can also operate at the community level, at the meso level, or at the aggregate level, at the macro level. So there you have a model that illustrates, so to say, the multiscale structures that we would like to work with in order to get a full causal picture of migration processes. And what do we have there? We have three scales of analysis: the micro level, the meso level, and the macro level. And on the right-hand side, you have, so to say, causal parameters that are hypothesized as driving migration processes at every scale. But the problem is that we have different causal parameters at every scale. The causal parameters that we need to study the macro level processes of migration is of course different than the causal parameters that we need to study in order to get a causal picture at the micro level. So what we have at the micro level, to give you a little more details, is the agent. So we believe that causation drives migration at the level of agents by the different reasons agents have to take the decision to leave their country. But then we have a second level, an upper level, the meso level. It's the level of the community. Of course, there is evidence that the decisions at the community level or at the level of the other agents can influence the individual decisions of every agent. And finally, of course, at the macro level, we have those general causal external parameters like political conflicts, wars, and climate change that are also, from which we have also evidence that they do drive migration process. So the big challenge is to get an integrated overview of what is going on between all scales. And the challenge, of course, is to conceptualize and theorize how we can couple those scales, because the evidence we possess, it seems that those levels of causation are separated because they are driven by different distinct causal parameters. So the proposal I want to defend is the following. Modeling migration as a complex system describes the links between causal external factors, the agency and mobility of multiple agents, and large-scale migration movements. In one word, what I believe is that if we consider migration as a complex system, we might be able to bridge the gaps between each scale and to give an integrated explanation of causation in migration systems. To do that, I contend that we need to do two things. First step, we need agent-based models that describe the mobility, interactions, and decisions of agents from which global migration patterns emerge at the lower level. Second step, we need a general multi-scale account of causation for complex systems. What's the plan for my presentation today? In the first section, I briefly tell you what is a complex system approach in migration science. In the second section, I explain the first step, the agent-based models. In section 3, I will briefly introduce what could be causality for complex systems and what philosophical assumptions we need to study in order to make some progress on causation in complex systems. And finally, I give you a brief overview of what are the results, limitations, and what is my contribution based on my research. So, first of all, what is a complex system approach? Well, for a complex systems are co-evolving multi-layered networks, a little bit like what I've been trying to show you before in the multiscale model that I introduced. And in those co-evolving multi-layer networks, what we have interactions of large number of entities that give rise to qualitatively new kinds of behavior, what we usually call emergence. These behaviors can be self-organization, memory, or adaptation, interesting behaviors in the case of migration. So, the second question you might ask you is, why should we consider global migration processes as a complex system? Well, Frans Villekens, an important migration scientist, claims that international migration has many features of a complex system. He states that agents drive the system through their interactions without central control. So they have the characteristic of autonomy. Agents adjust their behavior in response to endogenous and exogenous influences, which is adaptability. And finally, observable systematic patterns are a consequence of the behavior of units of the system, which is emergence. So you can see that there's a focus, according to that author, on the lower level, which on the basis of the states of the agents and their interactions that give rise to emerging, interesting, new kinds of behaviors. So what I'm doing here is to give you an overview of complexity in migration. So I took the general features that have been identified by James Ladyman and Carolina Wiesler in their book on complexity science. And what they do is that they identify 10 general features that they take to be necessary and sufficient conditions for a system to be conceived as a complex system. And then I compare those general features of complex systems with those that we can identify in systems of migration. And I took a paper from Frans Villekens, and what he does there is that he claims that migration systems do share the characteristics of complex systems. But you can see that some features are identified with stars. Those features are explicitly identified by Frans Villekens in his paper. The other features are identified with daggers, are features that I believe we could easily argue to be shared or to be that can be found in migration systems. So the bottom line here is that we have a very interesting analogy between complex systems and migration systems. And what I argue for is to push that analogy further and to see to what extent we can really consider migration systems as complex systems. But still, the problem is that we don't know what is causation in complex systems. and especially in complex systems of migration. So while Franz Willikens indicates that complex systems change continuously due to internal forces and external influences, such that a system's structure evolves, other scientists and philosophers have not explained how causation operates in complex systems of migration. So this is one further aspect that I want to study in my research. What is causation in a complex system? And of course, I'm using the case migration systems to see how causation can be operating in such a multi-scale structure. Okay, now I move to the second section of my presentation. I just give you a brief overview of why we need agent-based models to start to give a causal picture of causation in complex systems of migration. So according to Glabunde and Willikens, the aims of agent-based models is to uncover causal mechanisms. So this is what we need. So since agent-based models describe a system's behavior as an outcome of actions and interactions of agents, those models represent the actions, interactions, and mobility between agents. They describe the causal determinants that influence the dynamics between elements, subsystems, and systems. And they also indicate salient individual drivers, for example, specific life events, age, education, partnership, employment status of migration that are relevant for predictions. So, to obtain an overview of the causal dynamics of migration processes, an ideal agent-based model would describe the characteristics of agents and the decisions they make. We also need to know what are the interactions between agents. So these interactions could be exchange of information, cooperation and influence, or even competition. We also need to understand how community clusters are formed. And finally, what are the feedbacks between environmental factors and general human mobility? And this is why at the start, this is why I introduced the concept of causal loops in the title of my presentation, because there is evidence that there is no specific direction of causation in those multiscale structures, but that there is some kind of causal loops in a sense that the environment influences the mobility of agents, but then agents then transform their environment, and there's some kind of causal loops that is driving complex systems of migration. So it might be interesting to see to what extent there might be causal loops generally in complex systems. So usually to ground agent-based models, we need some kind of underlying theories that explain the decision of individual agents. Every agent-based model should be grounded in an adequate underlying theory of decision-making. By the way, that should interest philosophers, because still there's place for more progress in theories of decision-making in migration science, and philosophers have many conceptual and theoretical tools to develop some very interesting models for decision-making in migration science. But in any case, underlying theories can be economic, for example, neoclassical macro theory, microeconomic expected utility maximization, the theory of new economics, and world systems theory. They can also be social psychological, like the theory of planned behavior, and they can also be purely empirical, based on simple inferences from data analysis. So now what I would like to suggest is that we can introduce a different narrative in the explanation of how migration systems evolve. So I took as example a model suggested by Turner and colleagues, and it's a model for coevolution, and I think it could be very useful for migration science. So what do we have there? We have two dynamic, we have two co-evolving dynamic functions, f and g, and those functions are defined by two algorithmic equations. The equation that are presented there, number 1 and 2, And what we have, what those equations say is that the left-hand side term in the equation will be realized by our co-evolving dynamic functions f and g. And let me go slowly through the details. What we have in the first equation is the state denoted by the letter sigma of an agent at time t. And the equation says that the state of our agent sigma at time t will be realized by the function f. And what we have in the argument of the function f, first we have a parameter lambda, which is a set of environmental parameters. We also have a matrix of interaction M, which defines the type of interaction that we have between our agents. And the type of interaction is denoted by the upper index alpha at time t. And finally, we have the state sigma of another agent, j at time t. So the first equation says is that the state of an individual agent will be realized by what? By a set of environmental parameters, a type of interaction that there exists between our agents, and of course, the state of the other agent, which is, so to say, interacting with our agent. So this is a little bit, it gives you a feeling of the narrative that I was trying to explain before, to the extent of which that our agents are interacting together and that the set of environmental parameters drive those interactions. And what we have in the second equation, we have a new type of interaction defined by the matrix of interaction M, and the new type of interaction is denoted by the upper index beta at a future time step t prime. And again, we see that this matrix of interaction will be realized by a function g. What do we have there? The matrix of interaction that we had before. So in a sense, the first type of interaction that existed between our agents and the state of our agents that we had before. So we can conceive migration as a survival strategy in a sense that when the life conditions or the environmental parameters, so to say, are threatening the life condition of our agent, then there's a new type of interaction that evolves. And then we see that migration is some kind of strategy for agents to move, and that drives their mobility and to find some other places where life conditions are better, so to say. So now I'll move to the second section of my presentation, which is we need an account of causality, of causation for complex systems. So the problem here is that there are still open questions concerning causation and migration as soon as we conceive migration as a complex system. So since agent-based models do not include all salient causal variables, we still need to inquire if causation is operating elsewhere in our complex multiscale structure. Of course, as I tried to explain before, agent-based model give you an overview of the emergence of macro level behaviors as a function of the state of our agents and their interaction at the micro level. But still, we might want to ask, are causes only external, operating from outside at the environmental macro level? Can also ask, are the decisions, interactions, and flow of information in the community at the meso level the genuine causes of the mobility of every migrant? And finally, are causal chains based on the decisions of agents at the micro level? And of course, we also need to inquire what evidence do we have to answer every question. If we inquire, given a causal hypothesis related to a specific scale in our multiscale structure, what evidence do we have, so to say, to confirm those hypotheses? So there's a very interesting proposal defined by Andreas Wagner in a paper of 1999, and he tackles very explicitly the question of what could be causation in a complex system. So for him, causation in a complex system can be local or global. In other words, causation can be a function of interactions between elements within a system, that is at the micro level causation, or causation can also be a function of system parameters and exogenous variables at the boundaries of a system. So, in other words, we can have something like macro level causation. So, his proposal is coherent with what I was trying to say, is that we could have different levels of causation in a multiscale structure. So he suggests a definition of causation, which I contend is a little too liberal. I will explain afterwards why I think it is too liberal. But in any case, what he suggests is the following. For a given system S1 with a set omega of individual state variables, member of that set, omega with a potential value x at time t, representing either a physical quantity or the state of an agent, Wagner suggests that we can define a causal event as a change in a state variable x at time t, that being the cause, and then the corresponding effect will be a change observed through a differentials, a gradient, or simply by a qualitative state transition from a state alpha to a state beta in one or more state variables at the future time step t plus 1. Importantly, changes in the state variables cause changes in the subsequent structure and behavior of the system, which will be observed in the system's trajectory. So it's a very interesting definition, and it's a starting point. The only thing is it is too liberal in a sense that I believe if we take this definition for granted, then every change in a system that we are studying will count as causally induced. Of course, we are interested in complex systems, and those systems are dynamic systems. Those systems evolve, they keep evolving, and of course, there will be changes observed in those systems. But what we would like to be able to do is to differentiate random changes and causally induced changes. And according to his definition, this differentiation would be hard to do because any change in the evolution of a system would count as a causal event. In any case, it is a good starting point that, of course, we can criticize this definition, but it's just to give you a feeling of what we need to start with an investigation of causation in complex systems. So, based on what we've just seen before, the proposal of Andreas Wagner, I suggest that we could use that definition and upgrade the model of coevolution that I presented before and give it some kind of causal and predictive interpretation. So basically, we still have the same two algorithmic equations, but what we would be interested in seeing now is to predict the state of an element at the future time step, which is denoted here by the state sigma at the time step, at the next time step t plus 1. And what we have is basically the same function f, but we could give a causal interpretation to our parameter lambda in the argument of our function f, and give it a stronger causal interpretation. And the difference there is that we would like to be interested in studying or in considering the state of all agents in our system as far as this is possible. And again, we have the same upgrade of our matrix of interaction, upgraded to a new type of interaction defined by the upper index beta, and we'd like to predict to what extent the type of interaction will change as a function, again, of the states of the agents that we had before, and the first type of interaction denoted by the matrix of interaction, the type of interaction alpha. So I hope you can see in that model, the idea of causal loops, in a sense that the states of agents influence the type of interactions that we have between those agents, but in return, those interactions will change in the future the states of our agents, but they will also influence the type of interactions there are between our agents. And of course, we would like to consider to what extent causal external parameters have an influence on that coevolutionary process of migration. Okay, I will quickly move to, this is the last slide of the second section of my presentation, and I will move to the conclusion and I will be finished in approximately 2 or 3 minutes. So, finally, we still have to tackle the problem of multi-scale structures. As I said, we still have the same problem. There is no preferred level at which a causal description of migration systems should be furnished. We need to select salient causal variables and describe the relevant scales and processes that are involved. Thus, our ability to understand causation turns critically on our capacity to represent and explain the interactions and interdependence from multiple levels. So, in other words, there are competing causal assumptions that we need to study, and those causal assumptions are nicely defined by philosophical concepts. For example, someone would like to defend reductionism, the idea that multi-scale systems can be explained bottom-up. Sufficient information about the elements of a system suffices to explain the phenomenon at higher scales. Or somewhat, there's another competing philosophical assumption, which could be causal robustness. In contrast, one could defend the idea that the behavior of a system is insensitive to changes in its subsystem realization and fine-grained details. And finally, one could defend causal dependence or causal bridging. Subsystems are not self-contained. They give rise to emerging simplicity or sophistication through information feedback and coupling. So all causal approaches can be pragmatically justified depending on causal factors we need to isolate and describe. In other words, we need a multi-science approach to causation. Okay, so this is the last slide of the section 3, and then I'll move to the conclusion. In any case, I think that we have some kind of potential answers to the problem I introduced in my presentation. A complex system approach can describe how system parameters and exogenous variables causally affect the states of the elements. It can also describe how changes in the states of some elements causally affect other states. And finally, what are the causal loops between the elements, subsystems, and systems that affect the system's equilibrium? Perfect. So I move to the conclusion, and I will be finished in 2 minutes. Okay, so what are the results that I believe I obtained from my research? There is an important analogy between complex systems and migration systems that supports the objective of theorizing migration with complexity science. And a complex system approach, provides tools to represent and explain the causal structure shaping the linkages between humans, the environment, and their mobility. There are, nevertheless, limitations to that approach, and I would like to present them to you. I believe there are 3 central limitations to a complex system approach. First of all, what evidence or what data can support our complex system models and confirm that migration processes exhibit specific features of a complex system? Also, does the intricate structure of our complex system models represent the real migration flows? Finally, can we obtain accurate predictions for migration flows with those models? The general limitation that there is with that approach is even though the models I presented are interesting in that they give a novel perspective on the phenomenon of migration, we still need evidence or data that will be able to support our complex system models, and we will need evidence that real migration flows do indeed evolve as those models are trying to describe them. And finally, we would like to use those models to make accurate predictions. Is this possible? So those are important limitations. Finally, I would suggest that my contribution is to demonstrate the plausibility of a complex system approach to study causality, generally from a philosophical point of view, and also to demonstrate that causality can form the methodological core of the interdisciplinary study of global migration. So I will say again, thank you very much for your attention, and I'm looking forward for your comments, questions, and for a discussion. Thank you again.